Hello everyone, welcome to this weekly tutorial of calculus course. In this tutorial we will be covering the topics linearization of any function or approximating any function at a particular point using a particular linear function, and differentials. Both are almost the same thing, but in a different way. There are different ways to write both things. And then we'll have the derivatives of inverse trigonometric functions. So both are pretty easier topics. So we'll try to do multiple examples, and I'll give some practice questions as well. So let's start with the linearization. So we'll first recall an equation of a tangent line. If you remember the equation of a tangent line for any point A and B, where this A is your x axis part and this P is your y component, right? So if you have the line equation of line is given as y minus y1, which is this y component, and this m is slope, and then x minus x1, which is this x component. So this is the equation of the line that we have studied in pre-cal. Now if I write my function or the curve in this expression or in the function notation, then my a and b will becomes this x-axis will put in the function f of a, then this will become my y. So this a and b point will become a and f of a. So nothing will be changed, only that the y component will be changed to f of a, and the rest will be the same. Y minus f of a is equals to m into x minus a. So m is the slope. Now another thing that we have studied so far is that the slope is actually the gradient, and gradient is given by the derivative. So slope is nothing but the derivative of a function at a particular point. So since we want to find the derivative, we want to find the slope of this x function at point A, right? So it means the slope will be just the derivative of the function at point A. So we'll insert the point A, right? So we'll replace this m with this f prime of a. So we'll have this equation, and then we'll just move this f of a to this side, and we will get this equation. So now you see my y is equals to f of x. So this f of x is now I've written in this form, which is equal. So since this right hand side is a linear function, by linear I means there is only the power of x is 1 in this expression. This term is constant, this term is constant, some real number, this is variable, and this is also some number. So we have appearing only one power of x. So this whole expression is a linear function. So in other words, we are actually approximating my function. It doesn't matter whichever the function is. It can be a radical function, it can be degree 4, 5, 6, or any function. We can approximate this function using this formula, and this is called linearization, because this expression, the right hand side expression, this is a linear expression, so this is why we call it linearization. So if you are given with a function f of x and you want to approximate it linearly at a given point x equals to it, you will just use this formula. Okay. And differential is nothing, just the change in the y, how this linear function and the original function is getting changed, right? If we have a linear function, we have a function like this, and we approximate linearly like this here, then this change, let's say this change and this change, so this whole change will be my dy, right? This change is my del y, so this whole change will be my dy. Okay. But using formula, what will be the formula? We have in general what we say dy over dx, we write it as f prime of x. So imagine, so this is not a division of two component, but just for the understanding or just the way to remember it, if you write dy over dx equals to f prime of x, you will just differential dy will be equals to f prime of x times dx, kind of like dx is being multiplied here. Okay. So differential is dy is equals to f prime of x dx. So if you are given dx and you want to evaluate at a particular point x, then you will find derivative and you will put the derivative, you will replace the value x and then multiply with dx and you will get the differential. Okay, differential dy and change in y. Change in y we denote it as delta y. So both are different things. This is actually change in y, like delta x is change in x. So if we have, so if I draw a function, let's say we have a function here, okay, and we want to approximate this linearly here, okay. So let's say this is my x and this distance is a, it's very small, then this point will become x plus delta x. Now delta x is a, this delta x is basically equals to a, change in x. So x is changing from here to here. If you subtract x plus delta x minus x, so you will get this delta x, which is actually the change. So delta x is this thing, and delta y is basically change in f of x plus delta y, that is, so this is so you apply f here, you will get this value, and x is this, so you will subtract this minus this, you will get change in y, right? But dy differential is basically changing how this linear function and this graph is being changed. So this is about the differential. So don't worry about this now for like graphically, if you are getting confused graphically, so just forget about this. Just remember the formula. If you are being asked to find the differential of y, you will find dy is equals to f prime of x dx, and if you were asked to find the change in y or delta y, so we'll just use this formula, f of x plus delta x minus f of x. Okay, now so some exercise questions. For example, if we have y is equals to x square sine 3x and we need to find differentials. Differential is pretty easy because in this case we are not being asked to find at a particular point, it's general. So we'll just differentiate this expression, and this side we will get dy, and this side we will get the derivative, and then because we are differentiating it with respect to x, so we'll multiply with dx, okay? Or in other words, you can also differentiate it like this, dy over dx is equals to the derivative of this whole thing, whatever it appears. Then in the next step, this dx will be multiplied from this side, and you will get dy is equals to this whole derivative times dx. So this will be the differential. So I've written it here directly. Dy is equals to the derivative of this expression, that is this one, and then dx as it is. So now here we have two terms being multiplied, so we'll apply the product rule. First function as it is, derivative of second plus derivative, okay, so second as it is, derivative of first, और फिर 3x का derivative भी 3 आ जाएगा, तो we'll have this thing. So this is the product rule, और फिर साथ में dx as it is आ गया, so this is the differential. This is dy, okay. So another question, same, you just need to know how to apply, how to find derivative. So if y is equals to s divided by 1 plus s, then derivative of this with respect to s. So this is a typo here, x will not be here, we should have s here, dy is equals to, so we applied the quotient rule here. So नीचे वाला 1 plus s उसका square, नीचे वाला एज इट इज़ ऊपर वाला का डेरिवेटिव विच इज़ 1, सो ये एज इट इज़ आ गया, फिर ऊपर वाला एज इट इज़ नीचे वाला का डेरिवेटिव, इसका डेरिवेटिव 1 आ जाएगा, सो विल हैव 1 plus s minus s, you can cancel this s and s, you will have 1 over 1 plus s square times ds. So this is the differential, okay. Now the interesting questions are the linear approximation. So you should know how to approximate linearly any given number or function at a particular point, etc. So for example, we are given with a number 1.999 raised to the power 4, and we are not allowed to use the calculator, but we want to linearly approximate this function. Okay, so linearly approximation. Okay, so this maybe you can do the multiplication 4 times, which will still be a little lengthier task. But sometimes if we have like the power here is way bigger, like we have 44, 144, or we have 100, in that case linear approximation will be much helpful if you don't have the calculator. Anyways, so since we need to find a number raised to the power 4, so what will we do? We'll assume a function x to the power 4, and in this way, because what we do know that the linear approximation of any function, it depends functional value plus the derivative of the function at the particular value, and then x minus that particular value, right? So we want to linearly approximate this thing, and we want to linearly approximate this thing such that this L of x, this should be equals to, in our case this should be equals to 1.9999 raised to the power 4. So what we do, we take our this as x to the power 4, so this my f of x becomes x to the power 4. Okay, so what we assumed here is f of x is equals to x to the power 4, and since we want to approximate 1.99, this is very very close to 2, so we'll take our x equals to 2 or a equals to 2. Okay, so if x is equals to 2, then change in x, or you can just take my a, change in x, that is 0.001. del x is actually x minus x minus 0.001. This will become, so this x is in fact 2, this will become 1.999. so this is what we need. Okay, so we assume x equals to 2, we assume a function, and this value gives us that change in x is minus 0.001. now what we need to compute is, so because x is 2, so we need to compute f of 2. F of 2 is 16. Then we need to compute f prime of 2. First we take the derivative, which is 4x cube, derivative of x4, and then we'll compute f prime of 2. Then 4 into 2 raised to the power 3, 8 into 4, 32. So we have f prime of 2 is 32. Now we'll use the linear approximation, which is just nothing as the L of x is equals to f of 2 1.999 raised to the power 4 is equals to f of 2 plus f prime of 2 times delta x. Or you can write dx and delta x are same. Okay, so dy and delta y are not same, but dx and delta x both are same. Change in x or differential of x both are same. Dx is also change in x, but dy and delta y, they are not same. Okay, so this is delta x or dx. So we had delta x we put delta x values here, we put f prime of 2 here and f of 2 here, and now you just need to do this multiplication, which is just one multiplication. You can do it, and then you add 16, you will get the approximation of this number. Okay, so this was the linear approximation. You can also use differentials, and you can see this method. This is also pretty easy. Okay, now we have another question, that is we need to estimate this cube root of 1001. Right, this is again interesting because this is something 1001 raised to the power 1 over 3. So what we assume here, my function would be x raised to the power 1 over 3, and choose x is equals to 1000. 1000 because 1001 is very close to 1000. So if this is close to 1000, then my delta x is equals to 1. If this was 999, then my delta x would be -1 because this is smaller. So this is getting reduced, so we have -1 delta, but in this case this is adding +1, so delta is in plus sign, delta x. Okay, rest procedure is the same. So what do we need to do for this? So if we want to estimate f of 1001, this would be equals to f of 10 plus f prime of 10, because if x is equals to 1001, then 1000 times x plus delta x, which is plus 1. This is 1001 minus 100. Okay, this is basically delta x, so which is equals to 1, change in x, which is equals to 1. Okay. So we'll evaluate f of 1000, which is 10, because 10 to the cube is equals to 1000 and 1000 cube root is equals to 10. And then f prime of so now find derivative of x is equals to 1/3. You know how to find derivative using the power rule. 1/3 multiply हो जाएगा, then x is to the power 1/3 minus 1, which is minus 2/3. And then if you evaluate 1000 at this, you will get 1/3 10 to the power minus 2/3, which will be equals to 1/3 into 10 to the power 3 times minus 2/3. This will be cancels out. We'll have 1/3 into 10 to the power minus 2. We'll have 1/3 into 1/100, and then you will get 1/300. Okay. Thus you just need to put the values, and you will have 10 here from here and 1/300 here times 1. So multiply करेंगे, you will get this answer. So it's linear approximation. Similarly, tan 45, assume the function. Obviously this is tan x, and then x will be 45 and your a would be 44, and your delta x is -1 degree. So if you need to find the values in radians, because you will be applying this to here, you will applying these values here like this one and these two, so it's good to convert this degree into radians. So we convert this into radians. We know 1 degree is equals to pi over 180 radians, and this -1 degree, so we'll have minus pi over 180. And now we'll just evaluate f of 45, and then we'll find the derivative, which is secant square x, and then we'll find the f prime of 45 degree. And so we'll just insert the values, and we'll get the linear approximation. Okay, next is a statemental question, that is, if the radius of a circular disc is given as 24 centimeter. So radius of a circular disc, we have a circular disc. So we have a circular disc, radius is given as 24 centimeter with an error of 0.2 centimeter. So error is, it can be plus minus. Okay, now we need to use the differentials to estimate the maximum error in the calculated area of the disk. And what is the relative error, right? Okay, so these are the next part. So first of all, we need to find the maximum error in the calculated area. Okay, so first of all, we need to know what is the area. What is the formula for the area? That is A is equals to pi r square, and since error in the radius is 0.2 centimeters, so we'll have delta r, the radius, or change in the radius, this is equals to 0.2 centimeter, right? And now we need to find the calculated, so error in the calculated area, we need to find the differential of a dA, right? So dr delta r or dr both are same, so we need to find dA, and we know that area is equals to pi r square, and if we apply the differentials, we will have dA here, and then we have 2 pi r times differential dr. Okay, now 2 pi r we know the values, we'll just plug in the values, and dr we also know the value of dr, this is 0.2 centimeter. You'll just plug in the values, 2 times pi times 24 times 0.2 centimeter, and you will see that you will get 9.6 pi, or you can estimate it as 30.16 centimeter. This is maximum error in area. But if you need to find the relative error, so relative error means the area with respect to differential of a with respect to the area original, what will be the area, right? So you will just divide the differential with the area of the function, and area is, you just need to put the values here and you divide it by d, and you will get the relative error, which is very smaller. And if you want to find the percentage error, you just multiply the relative error with 100 and you will get the percentage. So this kind of the percentage can be the error, overall error in the area of the circular disc. Okay. Okay, then we have practice questions. You need to find the differentials, you know how to find it, you just need to find the derivatives, and then the differentials dy, you need to find differential dy and evaluate the value dy by for the given values of x and dx. Right, so if this is function, you know that dy is equals to f prime of at a point a dx. And so f prime of x, that x can be the value, and you have the differential dx. Okay, so you just need to find, first need to find the derivative of this function, which will be y prime is equals to 5 divided by 2 into 4 plus 5x. You will have this thing here, and then you will evaluate at 0, you will have this thing 0, and you will have 5 by 4 if you evaluate at 0. So you will have 5 by 4, and you need to multiply 5 by 4 with 0.004, you will have dy, you will get the number differential of dy. You can do the same, and also the linear approximation, we just did few questions here, you can use these questions here. Sine of 1 degree, what will be your guess for the function? What will you take the function? Yes, very good. F of x is equals to sine of x. And what will be your change? That will be del x will be 1 degree, and your x you are approximating at 0 degree. For this, what will be your guess? F of x is equals to x raised to the power 2 over 3. Very good. And the change will be 0.06. So delta x would be 0.06. Okay, for this you guess on your own, I'm not gonna tell. Okay, and this one is also the same, use differentials to estimate the amount. This is just a practice question, you can do it by your own. Okay, next we have the derivatives of inverse trigonometric functions. Okay, so first of all, instead of giving you direct the values or direct what is the derivatives or what are the formulas, let's see how to derive these formulas. So even if you forget somehow in the exam paper, you just know how to just quickly derive it, because it's very simple. For example, so we need to find the derivative of sine inverse of x. So what are actually the inverse functions? You guys already know from the pre-calculus, the inverse functions are the function that when we operate both functions, we get an identity. Okay, so the original function is sine of x. Its inverse, we write it as sine inverse of x, or we can also write it as arc sine of x. Both means the same. Okay, sine inverse of x, or you can write arc sine of x. Okay, so we need to find the derivative of sine inverse of x. So let's assume that sine inverse of x is equals to y. Okay, so now we know that if y is equals to f inverse of some number x, then this is equivalent as f of y is equals to x. So we apply the same formula here. Sine inverse of x is being applied here, and we are getting a y. So it means we will be applying sine on y, and we will be getting x, because they both are inverse functions. So we have sine of y is equals to x. Okay, now we need to find dy over dx. So what will we do? We'll differentiate this expression with respect to x, and the y term will get dy over dx, and sine y, the derivative of sine y is cos y, and the derivative of x with respect to x is 1, right? So this cos y will come here and will be divided, and now we'll use the Pythagorean identity, which is sine square x plus cos square x is equals to 1, because we have cos y and we want to write in terms of sine, because we know the value of sine y. So what we'll do, we'll write cos square of x is equals to 1 minus sine square of x, and cos of x is equals to 1 minus sine square of x square root, right? So in our case we have cos of y, so we'll have y here and y here. So you see, we have just replaced this thing here. So cos y is equals to 1 minus sine square y square root. Now sine y is equals to x, so sine square y will be equals to x square. So derivative of dy over dx is equals to 1 over 1 minus x square square root. It's very simple. And then for the cos of x, when we have y is equals to arc cos of x, we'll do that again. It's just the same procedure. Y is equals to inverse of x, cos y is equals to x. Now this time we need to find the derivative of cos y, which is negative of sine y. Then we'll have the same dy over dx, and then we do the same. Sine y can be written as 1 minus cos square y square root, but cos y is equals to x, so we'll have 1 minus x square square root, and this minus appears from here because derivative of cos y is equals to minus sine y. For cosecant inverse of x, we'll have cos y is equals to x, and the derivative of cos y is cosecant y cot y. So we have two terms there appearing, and then for the y part we have dy over dx. This minus sign appears, and again cosecant y can be replaced directly with x, so this can be replaced directly with x. But the cot y, we have the formula that cot square y is equals to x square minus y. X square means cosecant square y minus 1. So we'll just replace. So we have the formula cot square y is equals to cosecant square y minus 1, right? So this cosecant square y is replaced with this x, and we have x square minus 1. So we get this formula. So I've written all the derivatives of the functions, of the trigonometric functions. Derivative of sine inverse is equals to 1 minus x square square root. Derivative of tan inverse is equals to 1 over 1 plus x square. Derivative of secant inverse is equals to this thing. Derivative of this cos inverse, cot inverse, and cosecant inverse. So if you are not given the formula sheet of these inverse derivatives, you can derive it if you understand this process. Okay, then we have few examples that are solved, and then some practice questions that you will do on your own. Okay, so we have f of x equals to sine inverse of x minus 1. We can write it as f x is equals to 2 sine inverse of. Now here we will apply the chain rule, because we have one function and then inside we have another function. So we'll apply the chain rule, and the derivative f prime of x will be equals to this constant will appear as it is. Derivative of, okay, so let me repeat the chain rule. If we have f compose g of x. We want to differentiate this thing. This will be equals to derivative of f function, and in the argument we will have the g function times the derivative of g function, right? So here we will have डेरिवेटिव ऑफ साइन इनवर्स फंक्शन, बट आर्गूमेंट में x माइनस वन होगा. अब अगर यहाँ पे आप देखें साइन इनवर्स ऑफ x में आर्गूमेंट में x था, तो यहाँ पे x का स्क्वायर आएगा. तो अगर यहाँ पे आपके पास x माइनस वन होगा, तो यहाँ पे भी आपके पास x माइनस वन का स्क्वायर आ जाएगा. ओके, सो यू विल हैव साइन इनवर्स ऑफ x माइनस वन इज़ वन ओवर वन माइनस, अब यहाँ पे x स्क्वायर था तो यहाँ पे x माइनस वन का स्क्वायर आ जाएगा, एंड वी हैव अ स्क्वायर रूट. सो दिस इज़ द डेरिवेटिव ऑफ साइन इनवर्स, एंड आर्गूमेंट में हमारे पास x माइनस वन आ गया टाइम्स द आर्गूमेंट के अंदर जो फंक्शन है उसका डेरिवेटिव. तो डेरिवेटिव ऑफ x माइनस वन, दिस इज जस्ट वन. ओके, सो वी हैव, दिस इज द आंसर. ओके, सिमिलरली tan इनवर्स ऑफ x स्क्वायर रूट इज़ अगेन द सेम. आपके पास tan इनवर्स x का डेरिवेटिव जो है वन ओवर वन प्लस एक्स स्क्वायर आता है, वन प्लस एक्स स्क्वायर, तो यहाँ पे टाइपो है. दिस शुड बी एक्स स्क्वायर हेयर, एंड इफ वी गेट एक्स स्क्वायर हेयर, तो यहाँ पे एक्स स्क्वायर के बाद आपके पास जो है वो सॉरी, इट्स नॉट एक्स स्क्वायर, इट इज़ एक्स. बेसिकली यहाँ पे एक्स स्क्वायर रूट आना था और उसका स्क्वायर आना था, तो वो कैंसिल आउट हो गया. अगर मैं इसको यहाँ पे सिंपली लिखता हूँ, एफ ऑफ एक्स इज इक्वल्स टू tan inverse of square root x. So f prime of x will be equals to 1 over 1 plus x square root का square times derivative of x square root. This becomes square root और square cancel हो गया. We'll have 1 over 1 plus x times derivative of x square root is 1 over 2 into x square root. Now अब इसको combine करें तो we'll have 1 over 2 into x square root times 1 plus x. So this is the derivative. ओके, सो सिमिलरली हमारे पास यहाँ पे कुछ और क्वेश्चंस हैं, प्रैक्टिस क्वेश्चंस, और देर आल्सो प्रीटी इजी. अगर आप इसको सॉल्व करें, ट्राई करें यूजिंग दीज फार्मूलाज, तो इट विल बी अ नाइस वे टू प्रैक्टिस योर डेरिवेटिव्स एज वेल एज प्रैक्टिस योर चेन रूल. एंड ऑल्सो प्रैक्टिस करेंगे तो आपको मेमोराइज भी हो जाएंगे फार्मूलाज, सो इट विल बी very easy for you to implement in exam or in any form of questions. Okay, so that's all for this tutorial. We'll start chapter 4, which is about the application of differentiation, in which we'll see the maximum and minimum values probably after Eid. So I'll have the next tutorials in person inshallah, and we'll have the maximum and minimum values, and most importantly in the first derivative rule and the second derivative rule, and how to use this first and second derivative to find the relative maxima and minima of the functions. Okay, so please do try to attempt and solve these questions, and if you want me to check your attempts, please do send me your questions. I will check it, either send me an email or send me directly through WhatsApp. So I will check your questions and I'll try to comment on the questions. Okay, or if you want me to solve something for you, you can show me your attempt, what you have done, and then I'll guide you if you are doing correctly or you are doing incorrectly. Okay, thank you very much. Hafiz.